Hey everyone, welcome to another fun-filled day. Today we're going to be looking at the area model. We're going to be using this today to help us solve division problems. Now, you may say to yourself, wait, I know this area model. I've heard that before, and we used area model when we were solving products or when we were, that's the fancy word, using multiplication. And this is true because remember, is it going to fit? Remember that multiplication, geez, come on, pen. Multiplication and division, they are an inverse. They are opposite. They are related. And the cool thing about this inverse, meaning opposite, the cool thing about all of this is that if we know how to multiply, we know how to divide. Therefore, strategies we've used to help us multiply, we can use to help us divide. We're just going to do them a little bit different. We're going to kind of do them in an opposite way, right? So today we're going to explore the area model and actually how that can help us divide. And again, in our brain, we're probably going, oh, I remember the area model and how I use that to multiply. So that's going to be really helpful. Now, before I dive into the area model, I do want to explore and talk real quick about really what we mean by this, right? If I know how to multiply, I know how to divide. And I want to show again, like how the inverse can be so helpful in understanding. So let's take for an example, a problem like 3 times 5. And I'm going to do it quickly just to model it. So maybe we already know this answer, but again, let's think about how we solve this. Well, 3 times 5 tells me I have 3 groups. So I'm going to draw 1, 2, 3 groups. And in each one of those groups, I have 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if I was to count all of them up, right, I see I have 5, 10, 15. So that gets me an answer of 15. That's what we kind of call loops and groups or circles and stars, because sometimes we draw stars instead of tally marks, but I kind of like the tally marks. Makes it easier to count, if you ask me. So the inverse of that, right, the opposite of that then just states, oh, well, I would go backwards. And so if I was to draw this number sentence, trying to find the right color here. If I was to draw this number sentence right here backwards, if I was to draw it backwards, what that would state is 15. And I'm going to divide, because I'm doing the opposite, by 5. Now, technically, and let's kind of see what we get. We should probably get 3. But let's see, like, technically what that means. So if I have 15 divided by 5 and I model that, what I'm going to do is I'm going to break this into 5 groups. 1, 2, 3, 4, 5. And then I just start to split out the 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And you're right. Look, I have 3 in each. So again, we can look at this as how do we use these loops and groups in a backwards way to get similar answers and work. And I could even make these models the same, because what I could say, and not even could, I'm going to now to show that it would be exactly the same going backwards, is what if I changed these numbers around? I said, oh, I'm going to take 15 divided by 3. Well, I would make 3 circles. And then, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And what do you know? There's 5 in each. And look at this model. It looks exactly the same. So this is, again, where we use the same strategies, but we just kind of do them backwards, right? Here I drew 3 groups and I put 5 in each and I counted them to get 15. Here, I started with 15, so I drew through groups, and then I put 1 in each group until I was done, and I ended up with 5 in each group. And that's the same thing. 3 groups of 5 equals 15. 15 divided into 3 groups means there's 5 in each group. It's the exact same thing. Okay, so with that quick, hopefully quick, brief reminder of the inverse operation and why we can use opposite strategies, like use the same strategy but in a different way to solve division, right? Now we can go into the area model and say, okay, cool. Well, let's talk about the area model today. So why the area model is important and helpful is often when numbers get bigger. So this is a strategy I like to use when my numbers get bigger. And man, the top of the screen really does not like my pen at all. Wow, that is just horrific looking. So I have 64 divided by 4, even though it looks like it was like chewed up by a wild animal. But that says 64 divided by 4. Now, I could start and say, oh yeah, cool. You know, let's do 4 circles. And then let's start 1, 2, 3, 4, 5, 6, 7, 8. But I'm going to be here for a really long time if I do that. And because I have 64, like the number's just too big. Well, not too big. It will just take too long. So this is where we can use area model. Now to use area model, again, if we think about that idea of area and a model, well, then my brain is telling me, oh, I need an array. So what I'm going to do is I'm going to draw a rectangle because an array is a rectangle. And I'm going to think about how I can use this rectangle as a model to help me solve. And what I'm going to do in order to do that is I'm going to consider this whole rectangle 64, right? Because that's the number. Now, I know that this entire thing is 64, but instead of thinking about it as 64, what I want to do is I want to cut it into parts. So this side is my 4, because that's this, right? That's the other number we have here. But I'm going to actually take this 64 and I'm going to cut it into compatible pieces. Okay. And I'll show you like over here, this is how my brain's thinking. So I have 64 total. But instead of thinking about it as 64, I'm going to break it into more compatible parts. For example, I'm going to cut this slice here. I'm going to make it worth 4, which means I had 64 total, but I just made a slice of 4. So I have 60 left. And then let's see, numbers that are easier to work with for me. Honestly, I like 20. So I'm going to cut this into a slice, which means I have 40 left. And I like 40 because I'm working with 4. So this is going to be a 40. Okay, so note, let's squeeze this over here. That's 0. So I did it all. Note that all I'm really doing, and I know this can look confusing, but all I really did was say, oh, here's 64. But instead of dealing with 64, I'm going to deal with a piece that's 40 large, a piece that's 20 large, and a piece that's 4 large. And the thing is that still equals 64, right? 40 plus 20 plus 4 is still 64. So now I have to go back to that whole area model thing. And really all this is stating is we go back to remembering what an area model is. It's saying I have 4 on this side and my answer is 4 here. So I have to think 4 times what would equal 4. And then I have to think 4 times what would equal 20. And then I have to think 4 times what would equal 40. Because remember, this is like an area model, like this distance right here. Let me do that in a different color so it's clear. This distance right here of an area model would be 4 times what to make this center or this area equal 4. Well, I know that. That's 4 times 1. 4 times 1 equals 4. Now, I'm going to do the same thing. 4, let's do this in another color. 4 times what equals 20? Oh, well, that's 4 times 5, right? This is, again, where math facts come in so handy. So 4 times 5 is going to be 20. Now, last part. 4 times what is going to get me to 40? Well, again, these are math facts I know off the top of my head. And that's why I broke this down. It's 10, right? I broke this down into facts I knew. I made it easier. Instead of worrying about 64, I just broke it into easier parts. So if I'm now thinking, okay, cool, 64 divided by 4, well, to find my answer, I'm just going to add up these top numbers right here. And that is true if I put that together. 1 plus 5 is 6, plus 10 more is 16. So there we have it. Let me move this so we can kind of see. 64 divided by 4 equals 16. And again, we did that using an area model. Now, that was one time. So you're watching this the first time and you're like, what the, huh? Don't worry, that's natural. So let's just at least explore one more so it makes a little more sense. And again, the greatest thing about videos, stop, rewind, watch them again, and then they don't feel as confusing. So, oh, I don't know, I'm just gonna grab something. Let's say we take 140 this time and we're gonna divide it by 5. Now again, remember, I could draw 5 circles. I could, absolutely could do that. I could draw 5 circles and I could just start cutting up 140, but I'm gonna be here forever counting. So I'm gonna use the area model. Something we use to help us solve multiplication problems. So I'm gonna draw the area, because remember, area, array, array, rectangle. Those are all those words that go together. When I hear area, I should think array. When I think array, I should think draw a rectangle. And my rectangle, what I know, represents 140. Excuse me, 140. I can't believe I said n there. That's ridiculous. And on this side, it's my 5. So again, I am really just thinking like, okay, how do I get to 140 in groups of 5? Well, I'm not going to think about 140. I'm going to break this rectangle into parts that are compatible. So yes, I have 140, but the first thing I'm going to do is I'm going to take out a chunk of 40. So I'm going to draw and label this as 40. That leaves me with 100 left. Let's see, let's take a chunk of 50 out. Again, I am literally using numbers that in my brain feel good, right? These are numbers I'm randomly picking. You could start with a group of 10. You could start with a group of 20. Like you could start with things that make more sense to you. These are the numbers that my brain finds compatible. So I'm going to do another group of 50. And as again, you can see this section plus this section plus this section. 50 plus 50 is 100 plus 40 is 140. They equal the same thing. Now to help me think about that area model, now this is where I can use multiplication to help me solve division, because we're thinking 5 times what would get me 40, and then 5 times what would get me 50, and then 5 times what would get me the other 50. And when I have those answers, I'm just going to add those together, and that's the division part, because I'm thinking about these parts that I use. So I'm gonna put these up like empty boxes. So let's do that. So 5 times what equals 40? Oh, well, that's 5 times 8. It's a fact I know. Again, right? Using facts we know to solve things we don't. 5 times 8 is 40. 5 times 10 is 50. Actually, I know that. And this is exactly the same because it's the same fact. So now to figure out 140 divided by 5, I'm just going to add these top numbers together. So 10, 20, 8, 28. So there we have it. Oh, no, let's do that again. So there we have it. That was fun. We did have it. I don't know. Wow, there we go. When we take 140 and we divide it by 5, we get 28. Okay, and this is the area model. So always, it's new. So don't stress it if it feels weird. It's just natural. Try it, watch the video, rewind the videos, ask questions in class, do all the things that it takes to make sense of this. It feels complicated at first, but honestly, once it starts to make sense, it is a very effective strategy that's going to make division a lot easier on you. I promise. As always, thanks for being here, and we will see you next time.